Throughout the videos in the SMILE Equipment Breakdowns module, we explore the effects of voting equipment breakdowns on voter wait time. This video discusses the general findings and considerations when experiencing voting equipment breakdowns and implementing solutions at the polls. The explored voting processes are represented through two hypothetical polling locations. Polling location A's voting process consists of checking in at electronic poll books, hand marking paper ballots at privacy booths, and submitting ballots at an electronic ballot scanner. Polling location B's voting process consists of checking in at electronic poll books, marking ballots on an electronic ballot marking device, and submitting ballots at an electronic ballot scanner. By simulating voting processes in these polling locations, scenarios are generated in which voting equipment breaks down on Election Day and quantifies the effect of implementing several solutions to repair or replace broken equipment. Both polling locations are simulated with the assumption that voters arrive at the polling location following a pattern shown on screen, with 1,500 voters turning out to each location. This arrival pattern exhibits a peak of voter arrivals in the morning, a reduction in arrivals at midday, and a second peak later in the afternoon. Visual representations of the voting processes are currently shown on screen, with voters moving through the polling locations to cast their ballots. The results from this analysis indicate that voting equipment breakdowns can have a measurable impact on voter wait times if they are not repaired or replaced. The table on screen shows the overall average voter wait times when voting equipment breaks down at 8:15 a.m. on Election Day in polling location A. With a single broken electronic poll book, average voter wait times increase by 29 minutes. However, due to the voting process and allocation of resources, multiple device breakdowns and the breakdown of an electronic ballot scanner completely stalls the voting process. In polling location B, a broken electronic poll book increases average voter wait times by 19 minutes. A broken electronic ballot marking device increases average voter wait times by 4 minutes. When 4 electronic ballot marking devices break down, average voter wait times reach 1 hour and 37 minutes, a 1 hour and 11-minute increase. However, quickly repairing voting equipment or replacing the voting equipment with an analog alternative can assist in mitigating long voter wait times. The table on screen shows the average voter wait times on polling location A when broken equipment is repaired or replaced in 30 minutes. Repairing a single broken electronic poll book after 30 minutes results in an average voter wait time of 16 minutes, while repairing multiple broken electronic poll books results in an average voter wait time of 23 minutes. Repairing these devices prove more effective than replacing the broken equipment with a paper poll book, which yields an average voter wait time of 37 minutes. With the breakdown of an electronic ballot scanner, repairing the device after 30 minutes results in an average voter wait time of 17 minutes, while replacing the broken device with a ballot box yields an average voter wait time of 13 minutes. This indicates that both repair and replacement strategies are effective at mitigating long wait times when an electronic ballot scanner breaks down. Now, investigating wait times in polling location B, the table on screen shows the effect of repairing and replacing broken equipment after 30 minutes. With the breakdown of 1 electronic poll book, repairing the device results in an average voter wait time of 28 minutes. With multiple broken electronic poll books, the repair strategy yields an average voter wait time of 34 minutes. However, replacing the broken electronic poll books with a paper poll book offers an average wait time of 44 minutes, indicating that repairing the broken equipment may be the preferred option if possible. Considering broken electronic ballot marking devices, repairing a single or multiple device breakdown results in a 27-minute or 28-minute average voter wait time, respectively. With the breakdown of an electronic ballot scanner, repairing the device after 30 minutes results in an average voter wait time of 31 minutes. Replacing the broken electronic scanner with a ballot box after 30 minutes yields an average voter wait time of 28 minutes indicating that either repairing or replacing the device quickly effectively mitigates voter wait times. With these results, there are some considerations that must be made when switching electronic voting equipment to analog processes on Election Day. For instance, electronic voting equipment may offer features to voters and poll workers that cannot be replaced with analog processes, such as notifying voters of ballot errors when scanning a ballot into an electronic ballot scanner. Similarly, voters' perceptions of analog processes may cause concern or impact their confidence in their vote being counted correctly. Results of this analysis highlight that it is critical to establish plans for responding to equipment breakdowns. The availability of excess voting equipment, trained poll workers and technicians, and alternative solutions for overcoming broken voting equipment are critical for mitigating long voter wait times. Note that the degree to which voter wait times are affected by equipment breakdowns directly relate to the quantity of available voting equipment at a polling location, the level of voter turnout, and the pattern of voter arrivals. If a polling location has more voting equipment than is needed, a single device breakdown will have less of an effect on voter wait times. However, a polling location that has limited voting equipment will experience more of a challenge in reducing wait times, even if the broken equipment is repaired or replaced. The remaining videos in this module discuss scenarios in which a specific type of voting equipment breaks down and provide numerical examples using the simulated polling locations. Select another video in this module to learn more.